Section 6.1 is about rational expressions. A rational expression consists of a polynomial divided by a non-zero polynomial. So here's some examples of rational expressions. 3/4, x over 4, a over a plus b, x squared plus 7xy minus 4 over x cubed minus y cubed. Functions described by rational expressions are called rational functions. So we're going to look at example number 1. Here we're given a function, and this tells us how much time it would take for two machines working together to complete the job. We know that machine 1 can do it in t hours, while machine 2 can do it in t plus 5 hours. So we want to know how long would it take the machines working together if the first machine can do it in 1 hour and then in 6 hours. So we know our t function. So t is 1 and t is 6. So h of 1 would equal 1 squared plus 5 times 1. So we're substituting 1 in for t. So we would have 1 squared is 1, 5 times 1 is 5, 2 times 1 is 2, plus 5. So 1 plus 5 would be 6, 2 plus 5 would be 7. So it would take 6/7 of an hour if the two machines work together to complete the job. Then we look at, well, how long would it take for the two machines working together if it took machine number 1 6 hours to complete the job by itself? So we're looking at h of 6. So wherever there's a t, we replace it with a 6. So 6 squared plus 5 times 6 over 2 times 6 plus 5. 6 squared is 36. 5 times 6 is 30. 2 times 6 is 12 plus 5. So 36 plus 30 would be 66. 12 plus 5 is 17. So 66/17 of an hour, or 3 hours and 15/17 of an hour if we make it into a mixed number. So the next thing we're going to look at is how we can multiply our rational expressions together. So when you multiply rational expressions, you multiply the top and you multiply the bottom, where your bottoms cannot equal 0 because we know we can't divide by 0. So here in example number 2, we are asked to multiply. So I kind of like to make one big fraction bar. And I'm going to multiply my numerator, my tops, x times 3, and I'm going to multiply my bottoms, y10 times 3. So x times 3 is 3x. 10y times 3, I'm going to multiply my numbers, and I'm going to get 30y. Okay? We're going to talk about simplification in the next example. This is just getting us to multiply. So for b, I'm going to make my one fraction line, and I'm going to have 2x plus 15 times 4 and 7y times 4. So I have a binomial here, so I have to distribute 4 being multiplied by both my terms. So 2x times 4 would be 8x, 4 times 15 would be plus 60, then the bottom, multiply my numbers, and I get 28y. Okay? So in example 3 now we are going to talk about simplification. So in example 3, these have already been multiplied for us, and now we need to reduce them. So think about our factoring. So 24. I can rewrite 24 as 4 times 6. I can rewrite 30y as 5 times 6 times y. And if it's the same on top as bottom, then they can cancel each other out. So 6 on top, 6 on bottom cancels out, so I'm left with a 4 on top and a 5y in the denominator. In B, I have a binomial on top and I have a monomial on bottom. So just like factoring, the first thing I should think about is greatest common factors. So 8x plus 60, they have a 4 in common. So I factor out the 4, I'm left with 2x plus 15. 28, I know, can be 4 times 7 times y. And my 4 on top and my 4 on bottom can cancel, giving me 2x plus 15 over 7y. Okay, so let's look at example number 4. Now we want to write the following expressions in a simplified form. So just like we've been practicing in chapter 5, you got to think factoring when it comes to rational expressions. The first thing that comes to factoring is, do I have any GCFs? Treat your numerator and your denominator as separate terms. So 7t squared plus 21t has a 7t in common. I factor out a 7t and I'd be left with t plus 3. 14t, I can break this down to 7t times 2. The reason I broke that down there is because I know if I want to cancel something with my numerator to something in my denominator, they have to be the same thing. So 7t's and 7t's cancel out, leaving me with t plus 3 over 2. Okay? One thing we need to get in the habit of is when we have rational functions, we need to state something that we can't divide by. And we know that if it's in fractional form, I can't divide by 0. So you always look in the original or when you simplified it. And so I have one variable here. So I have to ask myself, where does 14t equals 0 at? If I divide by 14, then t cannot equal 0. 0 divided by 14 is 0. So here's my simplified form, and then I make a note that t cannot equal 0. And this note is stating that if it was 0, I would have something that's undefined because I can't divide by 0. So we're kind of stating the disclaimer is that t can be anything but this because we know we can't divide by 0. Example number 5. Example number 5, we are going to simplify the function and then state the domain. So think about my ways of factoring. Here, I have a trinomial on top and a is 1. So I make my x and I need to think about two numbers that multiply together to give me -10 that sum up to give me 3. And so I'd be looking at a 5 and a 2, and my 2 needs to be negative. So I can go right into x plus 5, x minus 2, over. In my bottom now, I have a trinomial, but a is greater than 1. So I have to multiply first. 2 times -2 would be -4. That sums up to give me -3. I'd be looking at -4 and +1. Then I go to my box. I have 2x squared. I have -4x. I have a positive x. And I have a -2. GCFs, 2x. GCFs, 1. GCF, x. GCF, -2. So this factors into 2x plus 1 and x minus 2. So when I cancel out, I can cancel out these two because my binomials are exactly the same. And I'd be left with x plus 5 over 2x plus 1. That is a simplified form. Now I have to state the domain. So my domain can be anything, but I can't divide by 0. So I have to determine where does my denominator equal 0. And I always determine that in the original or make it easier on yourself where we factored it. So we're going to set our two expressions equal to 0 to solve. Where does 2x plus 1 equal 0? Where does x minus 2 equal 0? So here, x would equal 2. Here, 2x would equal negative 1 divided by 2. X equals negative 1/2. I have to go back to my original because even though I was able to cancel this out in the simplified form, if I were to put 2 back into the original problem, I would get an undefined function. So my domain is saying I can be anything but negative 1/2 and positive 2. So I would be negative infinity to negative 1/2 in union with negative 1/2 to 2 in union with 2 to infinity. Okay. At any point, please stop, pause, rewind, rewatch certain of the parts of the video to make sure it makes sense to you. Example number 6. Here we are simplifying. So all we're really doing is just building off of chapter 5. Factor, 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 factor. But now it's saying, hey, factor on top, factor on bottom, and if they are like terms, then cancel each other out. So if I look at number 9, again, treat numerator different from denominator, I'm going to look here. First thing I look for is my GCFs. I can factor out a 3. So I'd be left with 3x squared plus 2xy minus y squared. In the bottom, I can factor out a 12, and I'd be left with x squared minus y squared. Use your GCFs because it will make the problem easier. So here, a is greater than 1, so I'm going to multiply a times c. So I'm looking for factors of negative 3 that sum up to me positive 2. So I'm looking at 3, negative 1. I make my box. I'm going to have 3x squared, 3x, y, negative 1xy, and negative y squared. GCFs, 3x, GCF, x, GCF, negative y, GCF, y. So in my top, I'm going to have my 3, which is my GCF, 3x minus y times x plus y. In the bottom, in the denominator, when I factored out this 12, I created a difference of squares. So I have my 12. I'll have x plus y, x minus y. Now I have to cancel out. So my binomials of x plus y cancels out. Now my numbers, my GCFs. 3 can go into 12 4 times. So what's left on my numerator? 3x minus y over, y times x minus y. 4 times x minus y. For b, there's nothing in my numerator that has something in common, only 4 minus t. In my denominator, I have a 3 in common, and I'm be left with t minus 4. 4 minus t is not the same thing as t minus 4. So I have to use my trick of my factor out a negative 1. So negative 1 is always kind of the trick pocket, because if I factor out a negative 1, whatever positive becomes negative, whatever negative becomes positive. Factoring out that negative 1, I now created the same binomial. So my t minus 4 can cancel out with my t minus 4, and I'm left with negative 1 divided by 3. Okay, so negative 1 is kind of your trick part that you can do, because we can always cancel things out when we have them like so. All right. Example 7. Example 7 is saying find the product and simplify if possible. So find the product means, hey, let's multiply. So just like we did at the beginning of the lesson, make one big fraction, or fraction bar, I guess we can call it. 10 times 14x over 7 times 15. I would suggest that you use prime factorization to see how we can get these numbers to cancel out. So 10 is 2 times 5. 14 is 7 times 2 times x. 7 is prime, so it's just 7 times 1. And 15 is 3 times 5. So if it's same on top, same on bottom, it cancels out. So in my numerator, I'm left with 2 times 2, which is 4, times x, over 3. So prime factorization means just how can I bring these down to prime numbers, or how can I maybe even make them composite numbers if I can see how I can break them apart. In B, we have 2x times x plus 7 over 3 times 10. So I just made one big fraction bar. Okay, so let's break down. My only thing that I can break down is I can break down this 10. So I'm going to have 2x times x plus 7 over 3 times 2 times 5. So the 2's cancel out. Nothing else can cancel out. I cannot break apart my binomials, okay? So binomials is two numbers linked together with addition or subtraction. They are stuck together unless we have the same thing that can cancel it out, like we looked at in our previous examples. So in the numerator, I'm left with x times x plus 7. In the denominator, I'm left with 3 times 5, which would be 15. And there is my solution. Okay, let's look at example 8. So now we have one that's in rational expression form, and here we just have a binomial. You can turn anything into a rational function by putting it over 1. So in my numerator, I have x plus 2 times x squared minus 4. In my denominator, I have x squared plus x minus 2. Factor. I have x plus 2. This is a difference of squares, so what times what can give me x squared is x and x. What times what can give me 4 is 2 times 2. Make one positive, make one negative. In the denominator, I have a trinomial. So what two numbers multiply together to give me negative 2, that sum up to give me 1, would be 2 and negative 1. So I have x plus 2, x minus 1. So only my like terms can cancel out. So my x plus 2 with my x plus 2. I can't cancel out these x's here because it's a binomial. They're stuck together. So I'm left with x plus 2, x plus 2. Sorry. Oh, this should be a minus, sorry, for difference of squares, positive, negative. So x plus 2, x minus 2 over x minus 1. I apologize for that. Okay, so you're just going about and simplifying your terms. Okay, you can do the same thing here with B. You have a difference of squares. You have to multiply, you have greatest common factors, and then you wouldn't even have to multiply then because you have a power of 1. Here you would have to multiply as you go. Okay. 9. Now we're dividing. Okay, we're going to treat division through multiplication. Dividing by your rational expressions is the same thing as multiplying by the reciprocal. So x minus 2 over x plus 1. Instead of dividing it by x plus 5 over x minus 3, we're going to multiply by the reciprocal, x minus 3 over x plus 5. So now we treat it the same way. We make one numerator, x minus 2 times x minus 3 over x plus 1, x plus 5. None of these can cancel out because none of them match. Okay? If we look at B, you would have x squared minus x over 2x plus 1 multiplied, flip it, x minus 2 over 3x minus 3. GCF and factor. Greatest common factor is an x. I'm left with x minus 1 over 2x plus 1 times greatest common factor in the denominator is 3. So I'm left with 3 times x minus 1. So I make one numerator, x times x minus 1, x minus 2, 2x plus 1 times 3 times x minus 1. Your x minus 1's cancel out. In the numerator, I am then left with x times x minus 2. In the denominator, I'm left with 3 times 2x plus 1. Okay, last example. Now we're just, again, we see the basics and then we expand upon it. So all we're doing is making our rational functions more factorable. So here we have a trinomial. So factors of 1 that multiply to give me 1, that add up to give me negative 2 would be negative 1 and negative 1. So I'm going to have a minus 1 over a plus 5 times, flip this, a minus 2. In the numerator, I have an a in common, so I factor it out. I'm left with a squared minus 1. So I'm going to have a minus 1 times a minus 1 over a plus 5 times a minus 2 over a, difference of squares, a plus 1, a minus 1. So I'm just going to extend my fraction. And so if it's the same on top, same on bottom, it cancels. So a minus 1, a minus 1. So I'm left with a minus 1 times a minus 2 over a plus 5 times a plus 1. And you can rearrange this. We can put that a out in front if we wanted to. And then it says, hey, list all of the restrictions on your domain. So when I'm going to do that, I'm going to go all the way before I simplified. I'm going to look where I have everything in factored form because it's easy to set everyone equal to 0. So a plus 5 equals 0, a equaling 0, a plus 1 equals 0, and a minus 1 equals 0. So what can a not equal? A cannot be negative 5, 0, negative 1, and positive 1. Those would be my restrictions because if a was any of those values, then you would get a 0 in your denominator.